Hello, welcome to the last video of video series 2. I'm just going to do a brief overview of the combined gas law. So we talked about the simple gas laws, so like Boyle's law, Charles' law, Avogadro's law, but you might see something called the combined gas law like this, or you may even see it with like an N1 and an N2 on the bottom. So like, what does this mean? Well, it's basically the same thing as all those laws, but just combined. So we use it when something is changing, just like we do with all the other gas laws. Um, but practically speaking, it's not that different from just using the laws themselves. Because say I have a problem where I have in a rigid container, and I have a sample, so a rigid closed container, and I have a sample of gas. So that means my amount and volume are constant. And then maybe it's asking that if I heat the gas, what pressure will the gas have now? Well, if the volume and the amount are staying constant anyways, this basically just looks like a pressure-temperature relationship, which we already explored with Gay-Lussac's law. So as you can see, it's a little redundant, but if you prefer using this form of the law instead of like just remembering the individual relationships, you can also do this too. But it is helpful to I find it personally helpful to use the simple gas laws because the relationships are pretty intuitive, right? Like if you're heating a gas molecules would go faster and they go crazier and they're more all over the place, thus increasing the volume. Or if you have a gas that's at a higher pressure, it's probably at a lower volume, right? Because if you have the same amount of gas, but then you like shrink it, all those gas molecules now have a smaller amount of surface area to knock around against. So it can be kind of intuitive, but it could be helpful if you only want to remember one formula to use the combined gas law. Okay, I'll see you guys in the next video, which will be going over some past AP problems involving the gas laws.